Hello everyone, I'm Nianlong from Lenovo Research. Today I'm excited to present our paper, a dual-stick controller for enhancing raycasting interactions with virtual objects. As VR controllers evolve, we see a trend towards lightweight pen-like design for more intuitive interactions, such as the Sony PlayStation Move and the Logitech VR Ink. However, two main challenges remain. First, the limited button space restricts smooth switching. Second, the limited degrees of freedom of rays restricts 3D manipulation, such as depth control and scaling. Our dual-stick controller addresses these issues with a novel dual-stick structure combined with dual-ray interaction. Let me walk you through the design process. We started by analyzing everyday stick-shaped handheld tools, categorizing them into 4 structural types and 5 grip postures. Among these, parallel sticks require skill to master. Mid-cross sticks act as first-class lever to save force, and N-cross sticks as third-class lever for speed and range of motion, exactly what VR interactions need. We also noticed that the N-cross structure maintains a natural spatial correspondence between physical manipulation and virtual ray control. This preserves user intuition, unlike the mid-cross structure, which creates reverse spatial mapping. In terms of grip design, both grab and tripod postures offered good pointing accuracy without the need for extra handles. However, the tripod grip demands sustained finger precision, leading to fatigue. The grab posture, in contrast, supports forearm stability more naturally. Furthermore, the tripod grip introduces asymmetric movement challenges, requiring constant reorientation. As a result, we choose the N-cross structure and grab posture as our default design. Our final prototype features two 150 mm long, 9 mm in diameter sticks. We also incorporated an 8 mm spring with a stiffness of 153.3 newtons per meter, allowing for a maximum opening of 40 degrees. Building on our dual-stick prototype, we created the dual-ray interaction system. Initially, the dual-ray selection mechanism was designed with 2 rays that clap and form a 0-degree angle, targeting the object simultaneously. We conducted a phase law study and found that when the index of difficulty exceeded 4, the error rate was above 40%. At IDs above 5, selection became nearly impossible. This issue arose because, unlike real world, without force resistance, the rays easily pass through the object. Additionally, the user needs to precisely and simultaneously control both rays, which is more challenging than using a single ray. This led us to rethink our design and search for improvements. To address this, we proposed improved selection strategy, using the cone-shaped region to clap the target, resolving ambiguities with a heuristic algorithm based on cumulative overlap, where I means the candidate target's number and t is the current time step. To calculate the delta S, we use the S-cone to represent cone-shaped volume circular projection area on the target's depth plane, the blue circular area. And S-overlap is the overlapping area between S-cone and the target's projection, the dark green overlapping area. And the process is illustrated in this video. For target manipulation, while separating the DOF enables more precise control, our design integrates higher DOF, enabling multiple actions to happen simultaneously. Object movement and rotation are tied to the dual-race center line, while changes in the race angle control scaling and depth adjustments. We also define single clap and double clap operations, which mimic single and double mouse clicks. This eliminates the need for mouse switching buttons. With a single clap, user can begin manipulating the object after selection and switch between scaling and depth adjustment. A double clap exists manipulation mode, allowing the user to select again. To assess the performance of dual ray, we conducted two studies. The first study focused on distant and dense target selection. We compared the dual ray with intent select, which uses a similar heuristic algorithm, and a single ray as a baseline. Participants were asked to select targets at two different densities and sizes using all three techniques. We measured completion time, error rates, and collected subject feedback. The results show that the dual ray was more efficient than traditional single-ray input. Selection time was reduced by 23.5%, and error rates dropped by 31.9%. However, it didn't outperform the heuristically enhanced single-ray technique, where selection time was similar but error rates were 9.4% higher with dual ray. This can be attributed to the absence of a distinct pointer, the reliance on user intuition, and the fact that the dual-stick system was still in its prototype phase. The second study evaluates the performance of dual ray in remote object manipulation. Participants were asked to move a cube to a target location while keeping its size and orientation consistent. We tested targets of different size and depths. We also measured the completion time and the mode switch frequency. The subject feedback is used the same Likert scale as study 1. The results show that the dual ray significantly reduced completion time by 21.6% and the number of mode switches by 65.8% compared to single ray. Additionally, dual ray was less affected by depth variations, as the default depth adjustment mode required recalibration even for targets at the same depth. In conclusion, we propose a dual-stick controller design which features an uncross structure and grab-based postures, along with an innovative buttonless clapping mechanism. We also introduced the dual-ray input paradigm, incorporating a heuristic-based selection mechanism and a haired-off manipulation system with seamless mode switching. Our two performance evaluation studies demonstrated that dual ray outperformed single ray input, achieving a 23.5% faster selection time and 31.9% fewer errors. It also reduced manipulation task completion time by 21.6% and mode switches by 65.8%. However, error rates for selection was slightly higher when compared to intent select. This is all of our work. Thank you.